Hi there everyone. Welcome to the video lectures on probability and random variable. I am Professor Mayur Gohil. In this video lecture I shall be dealing with the topic of what are moments. Now let us see how to calculate them and what are the formulas related to moments. Now this is a topic in statistics which is used because the quantities that we are going to derive, they are used to measure something called as skewness and kurtosis of the data. It helps you to understand whether the data is positively skewed, right, or negatively skewed, or it is on the right or on the left. And then there are certain coefficients developed based upon moments, so that is why this is very important. Later on it also helps us with probability also. Let x be a random variable, then the rth raw moment is denoted by mu r dash. That's why I have put it in this inverted colon over here. That is the Greek letter mu with the suffix r and super suffixed super prefixed on the top with a dash. Okay, it is just the notation mu r dash. So whenever you have dash in the above mu, it indicates it's the raw moment. Okay, so and mu r dash equals to expectation of x to the power r. Now this has two formulas. They are summation x raised to r, probability of x equals to x over x, this will run. This formula is to be used when x is a discrete random variable and p of x equals to x is the PMF of the discrete random variable x. So p of x equals to x is its PMF. Okay, so this is the formula when the random variable is discrete. When x is a continuous random variable, we have minus infinity to infinity x raised to r f x dx. Okay, so this formula is to be used when x is continuous random variable. Now over here we have f of x as PDF of x. So these are the two formulas for raw moment. Raw moment has only one main definition which is going to be here. This is the main definition. Okay, definition. But as the random variable type changes, you have a different formulas. So if x is discrete, you use the summation formula. If x is a continuous random variable, then you use the integration x raised to r f of x dx. This is the formula for the raw moment. Now there is one more concept like this. There is something called as central moment. Okay, so let us see the next concept. They are denoted by mu r. This is very important. There is a very slight difference between the raw moment and the central moment. Raw moment has mu r dash and central moment are just mu r. Okay, there is no dash on their top of their head. So please be very careful while writing difference between central moment and raw moment. Okay, they are denoted by mu r and given by the formula. The formula mu r equals expectation of x minus expectation of x whole to the power r. This is the formula. So mu r is expectation of x minus expectation of x to the power r. Now many times E of x is written as just x bar. Okay, so what the formula changes to, it changes to E of x minus x bar whole raised to r. Okay, now this formula, when we try to implement, we have to be very careful that, remember here, that E of x has been denoted by x bar. It is the concept of probability, so be very careful here that we note this fact here, that E of x is equals to x bar for this part of the concept. Now, just like the raw moment formula, there are two formulas here also, depending upon the type of the random variable we have to use. So for the discrete random variable, the formula will be summation x minus x bar to the power r p of x equal to x over x. Okay, and here it will be x is discrete RV. Okay, that is what it is over here. And in the continuous case of random variable, it will be minus of infinity to infinity x minus x bar whole to the power r f x dx. Here x is continuous RV. Okay, so these are the formulas for raw moment and central moment. Now comes the most important formula and a concept of moment generating function. It is in short written as MGF. Let us see what is the formula for moment generating function. So there is again here only one formula, the main definition, but then as per the type of the random variable, it will split into two. Okay, so the formula for MGF is as follows. Let x be a random variable, then MGF of x is denoted by this m suffix capital X of t, and it is given as mxt equal to expectation of e to the power tx. Now here x you see is a capital x, so that is the random variable x. Okay, so now again we see that this is going to split as per the format of the random variable. So here, so we take a note over here further, let's say, so that is mxt is e of e to the power tx, right? So this will split up and it will give us summation e to the power tx times probability of x equal to x. So that is the PMF basically. And now this is the runner over whatever values of x are there, and when it is the continuous random variable, so it will be minus infinity to infinity e raised to tx fx dx. Okay, so here x is discrete RV, and here x is continuous RV. Okay, now this is what I wanted to give you regarding moment generating function. Okay, now there is one important thing regarding moment generating function, that is one property of MGF is, okay, if we take the rth derivative over here with respect to t and evaluate this rth derivative at t equal to 0, then what we get here is the rth raw moment. Okay, So this is the property that can be useful at lot number of times for finding the earth raw moment from MGF. Okay, so there are other properties also for MGF. I won't go into great detail about it. Right now what is important for us is to understand these properties and use them for solving the various other questions related to it. So this was basically the theory regarding the raw moment, central moment, and moment generating function. There is much more detail about the same topic. We will see them as we proceed ahead. I hope you understood this basic theory of moment generating function and you found it comfortable, and I have tried to give you in the most easiest and the simplest manner possible over here. So I hope you liked it. Please hit like button, share it with your friends, those who find this topic useful. I'll see you soon in the next video lecture. Thank you.